This is what the road to human immortality looks like. To battle aging, people receive customized fountain of youth treatments, DNA repair, cellular rejuvenation, or even organ replacement. The realistic prospect of healthy, eternal life is fundamentally reshaping society.
Ooh, this I want to try.
Today, scientists are blazing a trail to this very future.
We are at war with death.
I want to know what breakthroughs are being made.
We can build an organ that matches your body.
This cocktail seems to reverse aging.
That will forge the future to
So complex.
human immortality. My name is Maren Hunsberger. I'm a microbiologist, and I'm fascinated by how the future inspires the progress of science and technology. But I'm critical of sensational science headlines that promise immortality. Still, all of these stories have prompted me to ask, how quickly am I aging? To find out, I recently took a blood test. I mailed it off, and now the results have just come in.
I, in real life, am 26, and we're about to see what this biological aging test says I am. So, my biological age, according to this test, is 40.
Learning my body has aged 14 years faster than expected is not the result I was hoping for, but it makes sense. My life partner was recently diagnosed with cancer, and I guess that stress has clearly taken a toll. While I have some doubts about the accuracy of this particular test, I am concerned that stress could further affect my health in the future. So I want to find out, is it scientifically possible to slow or even stop the aging process altogether? If so, what will our lives be like in the future?
Wow, we're in Vegas.
To find out, I'm attending RadFest, where a group of experts are gathering to put an end to old age. This event bills itself as the Woodstock of radical life extension.
We want to create a mass movement to save lives.
I'm immediately struck by the extremely bold claims of healing and even immortality.
We're immortalists. We're into immortality. That's what we're about. You're doing really good and life is great. You're going to want to keep on going. So what do you think?
Festival director James Stroll calls himself an anti-death activist.
I want to live indefinite lifespans. That's what I'm after. I want to live forever. That's my goal, okay? I personally think it's better to go for it and lose than not try at all, right?
Sure. What perceptions about aging and death in the public are you hoping to change? What would you want people to take away from it?
Most people are pretty much, I'll use the term programmed, that death is inevitable. And we want to change that paradigm. We see aging as a disease, a curable disease. And we're at war with death.
The idea that aging might be cured like a disease is relatively new. But this yearning for eternal youth goes back thousands of years. Cleopatra supposedly bathed in sour donkey's milk to make her skin appear more youthful. And since then, people have tried using everything from raw meat to guinea pig testicles and even menstrual blood to combat the aging process. Blood appears to be a recurring theme in this quest for immortality. Some ultra-wealthy patients are trying a controversial new therapy. They're receiving transfusions of blood products taken from teenagers in the hopes of rewinding their biological clocks. So far, this process has yielded no measurable benefits. There are dozens of therapies available at the Radfest marketplace. I'm wondering, are their claims based on sound science?
Ooh, this I want to try.
This procedure claims to boost a person's energy at the cellular level
What?
while reducing stress and anxiety.
How does the red light rejuvenate my mitochondria?
A lot of the research looks at decreasing the inflammation, improving the blood flow.
This treatment is supposed to boost the immune system.
These machines are hydrogen inhalation devices.
What's the
And you'll
hydrogen
see-
supposed to
Yep,
do?
so it's basically a master antioxidant and anti-inflammatory.
This device promises to relieve pain throughout the entire body.
So this is the Avicin.
Uh-huh.
What this does is it infuses heat throughout your circulatory system.
Just by delivering heat to my hand?
Yes. And they also have done research in the diabetes arena, cardiovascular, and also autism.
The spiel that they have contains a lot of scientific words peppered in there, which are legitimate scientific words that refer to a real phenomenon. But it plays into this idea that anything that sounds science-y is true and that you should believe it and trust it. But that does not mean that their product is going to make you live longer.
Though I'm sympathetic to the anti-aging cause for very personal reasons, from a scientific point of view, I don't think the remedies on display here will lead us down the path toward immortality in the future. To find a more realistic path, I'm at the Massachusetts Institute of Technology to meet a pioneer in longevity research, Dr. Leonard Garente. He's taking on a big problem that most everyone will eventually face.
As you get older, you lose muscle mass and you gain fat mass.
Okay.
And both of those things are bad.
Sure.
Lenny is a firm believer in the power of exercise to keep our bodies healthier for longer.
By impacting aging, you can not only improve health, but help mitigate diseases.
At his cutting-edge lab, his team identified the first longevity gene. And this breakthrough opened the door to the possibility that we might one day control the aging process in living organisms.
I think the best case scenario is attempting really to maintain what we call health span. If people live healthier lives for as long as possible and really compress morbidity to a very short period at the end of life. That's my goal.
Instead of slowly declining in our 60s, plagued by things like heart disease, dementia, and cancer, Lenny thinks we could live until 90 and then make a fast and relatively peaceful decline into death. To make this a reality, Lenny is combating the aging process at the cellular level.
So I'd love to walk through the molecular, cellular basis of aging and what's happening in our cells as we age.
Okay.
Yeah.
Let me draw a cell.
Okay.
So there's the cell, mitochondria. They produce the energy. This will be the nucleus here.
Okay.
Chromosome, the DNA.
DNA contains all of the information for maintaining cells and building new ones, and those cells are busy dividing. But here's the problem for achieving immortality. Cells have a kind of internal time limit. After about 50 replications, they can't divide anymore. This roadblock is known as the Hayflick limit. On top of that, as a person's cells divide, they also accumulate damage and release toxic waste byproducts. As these toxins build up over time, the affected cells gradually lose their ability to function. This is the aging process at the cellular level.
That's the important thing about living critters is we do have things break down, but we also have the ability to repair damage.
Sure.
In principle, the goal would be to boost the ability to repair the damage.
To capitalize on this process of regeneration, Lenny and his team targeted a gene in live roundworms called SIR2. SIR2 genes create proteins called sirtuins. These sirtuins coordinate the cell's response to stress, including repairing DNA damage, which can slow the aging process.
Oh my gosh.
They're alive. They
Yeah.
should be moving.
Oh yeah, they're moving around. They look like little threads.
So we first looked at the roundworms, and we found that, yes, the worm's SIR2 gene was involved in aging. And so by extension, then, we think this is going to be true universally. And there's a tremendous amount of evidence now that shows that these sirtuins regulate aging.
By inserting extra copies of the SIR2 gene into the worm, Lenny and his colleagues can interrupt the aging process and increase the lifespan of a worm by 50%. That's the equivalent of increasing the global average human lifespan from 72 to 108.
What we know about sirtuins is that we can intervene and make people healthy for a decade longer than they are now.
Lenny has found a fascinating connection between these genes and the body's natural survival mechanisms. And it upturns many of our assumptions. Studies of mice and rhesus monkeys suggest that the production of sirtuins increases in times of stress, including when food is scarce.
Animals on a very low-calorie diet age more slowly.
That's so insane to me.
That means you can identify compounds that increase the activity of sirtuins, that mimic what calorie restriction would normally do.
Right, so you don't actually have to calorie restrict.
Exactly.
This process gives all the health benefits of a low-calorie diet without going hungry. Lenny wants to apply this discovery to everyone. He is now testing a new dietary supplement to increase the activity of sirtuins in humans.
So that's one of those rare moments where in an instant you have something that you know is gonna be big.
That was kind of, I believe, was the aha moment. That's really the only time I've ever experienced something like that.
Wow.
By pushing the limits at the cellular level, Lenny's research could forge a future path toward human immortality.
In the future, a high-tech procedure optimizes health spans. The treatment stimulates longevity genes and mimics full-body calorie restriction. This regular toxin cleanse and cellular rejuvenation extends lifelong health to averages well past 125.
Even if scientists can slow aging like this, how will it actually feel physically to grow this old? Over at the MIT Age Lab, Samantha Brady is exploring the impact of extended longevity on the function of the human body.
We are in this unprecedented time of longevity. Back in the 1900s, average lifespan for people was about late 40s.
Seriously?
So that's crazy to think about.
I did not know that.
Everyone is living longer lives thanks to advances like greater access to clean water, antibiotics, and vaccines.
Now we have about a 30-year bonus.
But it's not all rosy. Sam helped develop a suit that, well, simulates what my body might feel like at upwards of 70.
So we're gonna start with this weighted vest.
Okay.
This is one of the pieces that's gonna help simulate what muscle loss might feel like.
Okay.
We'll just strap you in.
This suit mimics the shortening of our ligaments.
Oh my God, they're heavy.
Spinal compression, and the loss of balance that occurs as the years go by.
Let's pop the goggles on.
It also simulates loss of vision and hearing.
You are now Agnes.
Transformation complete. I definitely feel like a different person.
I always imagine myself enjoying my life as I get older.
Give it a shot.
That's about as far as I can go.
But it's pretty hard to do anything in this suit.
Whew. Yeah, that's rough. I can get my knees a couple of inches off the floor and that's it.
Now, I'm worried that as I age, I won't be able to do the things I love anymore.
So it looks like this is pretty tiring already with just the couple moves that you did.
Exhausted.
And I keep thinking about the results from my biological aging test, which mean this could be a reality for me sooner than expected. It's actually pretty terrifying.
Can't wait till I can take it off. And then imagining like, there are some people who can't take it off.
This is clearly not how people want to feel when they are 100, 150, or ever. The decline of muscles and the skeletal system is just the tip of the iceberg. As cells stop dividing, they accumulate damage, which ultimately can cause tissue and organs to fail. In the heart, this means valves and the muscle itself can become thicker and stiffen, reducing blood flow. Incredibly, heart disease is actually the #1 cause of death around the world. And to combat organ failure like this, scientists are working around the clock to find unique solutions. I'm in Houston, Texas, to meet a scientist who could revolutionize the way we source organs for transplants.
She's often been called the Dr. Frankenstein of this area, and so I am bringing her a little gift.
Dr. Doris Taylor is growing hearts in the lab. And she's closer than ever to making lab-grown organ transplants for humans a reality.
I have a gift for you.
Oh, I don't normally get a heart as a gift. How cool is that? We call these our ghost hearts.
Ghost hearts?
It's amazing to see the engineered organs up close.
This is a rabbit heart, and it's about the size of a pediatric newborn human heart.
Oh, wow. Doris, can you tell me how you got into a field like this?
I wanted to make a difference in the world. My twin brother was sick his entire life, and then when I was 6, my dad died. It motivates me when I think about that feeling of helplessness to want to make a difference in the lives of people with disease.
Because people are living longer with heart disease, many people develop heart failure. The only definitive cure for heart failure is a heart transplant.
Every 10 minutes, a new person goes on the organ transplant waiting list. So clearly, people don't get the organs they need. We can change that. We can build an organ that matches your body, and you can live longer and live healthier.
The first step Doris takes in building a new heart is to strip the tissue and cells from an animal heart using a wash of detergents. What remains is effectively the protein scaffolding of a heart.
If you look at this is the pig heart that we've washed all the blood out of.
It's so complex.
It's beautiful.
It is.
It's beautiful. It's humbling. You're holding an organ.
The next step is to grow a new human heart on top of this animal scaffolding. Doris does this by recellularizing the organ with human stem cells.
Stem cells are cells that are found in every organ or tissue. We all have stem cells. They're cells that respond to their environment and become like the cells that surround them.
Certain types of stem cells can transform into any kind of cell, from blood to liver to heart. Key to the process, these stem cells replicate much more than regular cells. This allows them to grow and cover the heart scaffolding very quickly.
This is one of the rabbit hearts that we've put cells in.
Oh my gosh, it's in there.
You can see that we're getting electrical activity here from.
So this is like an EKG.
So this is
for
an
that
EKG,
heart in there.
The EKG machine, or electrocardiogram, measures the electrical activity of a beating heart. So one thing is clear, it's alive.
I can see it moving.
Doris believes that her technique for building implantable hearts could be used to grow other organs as well.
But I truly believe if we can go to Mars, we're going to Mars in the lab. We got the rocket ship, the scaffold.
Yeah.
We've put the astronauts on board, the cells.
Yep.
And now we just got to prove it's
Blast
safe.
off. You guys are getting there.
Yeah.
And within a decade, she thinks she'll be able to surgically implant lab-grown organs like these for people in need. I find this hugely moving.
I had a patient say, "You're not building organs, you're building hope."
This is a path to the future I think we can all hope for.
In the future, body part farms exist in most hospitals on Earth. Organs and limbs can be 3D printed to order. But for emergencies, prefabricated organs are available in all blood types and body sizes. With the assistance of robotic surgeons, body parts can be replaced in under 8 minutes. Severe accidents and injuries are no longer fatal.
In my quest to unravel the mystery of the aging process, I'm finding that, like me, many scientists are doing this for personal reasons.
Earlier this year, my partner was diagnosed with Burkitt's lymphoma, and it's the fastest growing human cancer. We just had to think so much more about the end of our lives in a way that you don't have to usually until you're well into the later part of your life.
To find a pathway that will lead us toward longer and healthier lives, researchers are going deep into the jungle and to the bottom of the ocean. There, scientists have found that bowhead whales and Greenland sharks can live well over 200 years, while killer whales live no more than 50. What makes some creatures live longer than others? To find out, I'm at an aquarium in Las Vegas to talk with the legendary gerontologist Aubrey de Grey about another long-lived sea creature, the lobster.
The big thing that's special about lobsters is that they live a really long time.
There are now reports of lobsters having lived longer than any human has lived, which is 122 years.
Incredibly, this crustacean doesn't age, at least not in the way humans do.
The other thing that lobsters have, the really big thing they have, is they grow and grow and grow as long as they live.
Unlike humans, a lobster's cells never stop dividing, so this creature never stops growing. They may die due to predation or disease, but not old age. Why does the lobster live so long? The answer can be found in something called telomeres. Humans also have telomeres. Telomeres are repeating sequences of DNA at the ends of chromosomes. If chromosomes were shoelaces, then telomeres would be the little protective caps at the tips. These caps protect DNA during cell division. But as our cells divide throughout our lifetime, these telomeres gradually shorten. When the telomeres become too short, the cell stops dividing and eventually dies. However, there is an enzyme called telomerase that helps maintain these protective caps. Incredibly, lobster telomeres do not appear to get shorter over time. Many believe this protective enzyme is the secret to their long lifespan. Scientists are currently devising telomerase treatments to try and produce the same life-extending effect in humans.
What do you think a child born today, how long could they possibly live?
So really there is no limit to how long someone can live.
Aubrey tells me that a child born today could benefit from constant scientific breakthroughs. A treatment at 80 years old might allow them to live to 130, and future treatments could allow them to extend their lives potentially for forever.
That means that the only limit to longevity is causes of death that do not have to do with how long ago one was born, being hit by trucks.
Bolstering telomeres isn't the only way to extend human life at the cellular level. At his lab in California, Aubrey is advancing the science of anti-aging in another area. He believes that a lot of the problems associated with aging happen when cells become what's called senescent. They don't divide anymore, but they don't go away either.
Some people call them zombie cells, essentially undead. They're secreting nasty chemicals that are toxic to their neighbors and so on, but they're not dying.
So one of the most key developments, in your opinion, you think, is in essence, getting cells to be better at taking their own trash out.
Oh, yeah.
Using gene therapies, Aubrey believes removing these zombie-like senescent cells will radically extend our lives.
It turns out that we were able to exploit some really great technology that was developed for a completely different reason, the technology of what's called bioremediation, which is used in environmental decontamination.
To clean up pollutants.
That's right.
They eat up the oil or the chemical or whatever it may be.
So we do the same thing. We identify bacteria that are able to break down the thing that we're interested in. We identify the genes that they have that allow them to have this capacity, and we put those genes into our own cells.
By inserting these new bacterial genes, our bodies might be able to eliminate these zombie senescent cells.
Most people didn't take me seriously at all at first.
Interesting.
But now this is a totally mainstream idea.
While some remain skeptical of Aubrey's approach, a handful of biotech companies are also taking aim at senescent cells.
I've never thought of aging and death as anything but inevitable, so to think of that not happening, I think really upends my worldview.
In the future, a revolutionary new treatment to destroy zombie cells is extending human life across the planet. While resting in an oxygen-filled chamber, individuals are injected with thousands of miniature robots smaller than red blood cells. This army of nanobots scour the body to hunt down and destroy every last toxic senescent cell. One treatment every year starting at age 20 extends most human lives by 50%.
Living to 200 years of age or more may seem like science fiction, and the big challenge in making it science fact lies in getting these practices to work not just in lab animals, but in humans. In Indiana, one community has already made steps toward hacking the aging code without even knowing it. Dr. Doug Vaughn of Northwestern University has identified a unique and isolated group of people, many of whom are living dramatically longer than average lives. And it's not who you might expect.
There is a large, old order Amish community here that settled this region in the early 1800s.
From Switzerland,
From
right?
Switzerland, yeah. They're living a lifestyle that's very, very homogenous.
The Amish avoid modern technology and farm using the same traditional tools as their ancestors.
We brought 200 members of the community into this center, and over 2 days, extensively studied them, did all kinds of things to measure their biological age as opposed to their chronological age. Took blood samples, measured their blood pressure, measured their telomere length.
For Doug, the results are astonishing.
At multiple levels, it looks like some are protected from aging. Their telomeres are longer, about 10% longer. They also have a more juvenile cardiovascular system. They're completely protected from diabetes, which is rather remarkable. That might have been the most striking finding in our studies because insulin is thought to be a driver of aging and aging-like pathologies.
What is their secret to a long life? Is it family history? The Amish lifestyle? One member of the Amish community, Neville, has agreed to talk to me, but for cultural reasons, he's asked that we don't show his face.
So it seems peaceful too and restful.
Yeah, it does get stressful some days, trust me.
I can.
This is my horse. Her name is Bee.
Hi, Bee.
And she's our source of transportation.
His family's lifespans are especially impressive when measured up to the average global lifespan, which is 72.
I understand you had some long-lived family members back in your family tree. Who were they?
One was my great-grandfather. He lived to be 92 years old.
Wow.
And my grandmother lived to be 86.
Wow.
My great-grandfather had some brothers that lived to be over 100.
Wow.
Yeah.
I can only wonder why this is the case.
Can you tell me a little more about your lifestyle?
We like to keep it simple, try to be as self-sufficient as possible, try to raise our own food from the garden. We're just people like you are, you know, so I kind of think that it just depends on what cards get dealt to your hand.
And it turns out Neville is right. Some in this community have won the genetic lottery. Doug's research is revealing what that is.
Good afternoon, I'm Dr. Vaughn.
The first clues to the Amish community's longevity recently surfaced when a member with a particular blood disorder visited a modern clinic.
Do you have any family members that have that bleeding problem that's present in some of the community around here?
My dad, I think he's a carrier, but none of us is bleeder.
This bleeding disorder is the result of a genetic variation that isn't found anywhere else in the world.
The original founder of the mutation married into the community in the early 1800s.
Wow.
He had 15 children and 148 grandchildren in the mid-1800s.
Wow.
Do the math.
The genetic variation in this Amish community occurs in a particular gene that creates a protein called PI1. Among other things, the PI1 protein controls the body's senescent or zombie cells. Doug's research reveals that those in the community with a single copy of the gene mutation produce more PI1 proteins than those with the bleeding disorder, but less than the general population. And they live dramatically longer lives. Why? It turns out it's all about balance.
PI1 contributes to a variety of different disease processes. It's not good to have a lot of PI1. It's not good to have no PI1. It's good to be in the Goldilocks zone and have somewhere in the middle.
Doug wants to hack the aging code by developing medication that essentially mimics this mutation and regulates the PI1 protein.
I have a collaborator now in Japan, and after screening a library of over 3 million compounds, they came up with a group of chemicals that looked like they might be candidates as PI1 inhibitors. We've used it in a variety of experimental studies around the world. It has remarkable effects in terms of insulin resistance, even impacting on the development of arteriosclerosis or vascular stiffening, if you will.
I came into this whole adventure being pretty skeptical about a lot of it, but I think digging deeper into the biology has made me feel that we're at the beginnings of something really big here.
Exactly.
It's a lucky finding. I'd never have imagined that a self-isolated community's genetic variation would upend the way scientists think about everyone's lifespans. Blazing a trail to immortality seems more plausible than I ever imagined.
In the future, most babies are conceived through in vitro fertilization, where it's possible to slow the aging process before birth. First, parents choose from a menu of longevity genes, including the Amish variant. Technicians then customize and engineer the egg's DNA before fertilization. Through this medically regulated conception, newborns can expect to live 200 healthy years or more.
While this kind of future seems appealing, what might a healthy multi-centenarian actually look like? To get a clearer picture of this future, I'm in Los Angeles to meet Lillian Solomon. She just celebrated her 100th birthday, and by all accounts, she is the living embodiment of what all these scientists aim to achieve. She is healthy, active, and alert. She is a bowling champion and even has a new boyfriend.
I brought you a little cake for us to all share.
Oh, look at that. This is my boyfriend, Eddie.
She's 11 months older than I am.
Nice.
I like older women.
I have arthritis, and I have all the aches and pains that elderly people get, but somehow it just doesn't seem as bad. I try not to let it deter me from doing what I want to do. As a matter of fact, I'd like to take you to the park and perhaps show you how I exercise.
Oh, yes, please. I need some tips.
More people are living to over 100 than ever before. While genetics and diet are important, some recent studies show other key aspects are at play as well.
On the road again.
What's the secret to staying young for your whole life?
I think really number one is attitude. I think if you have a good attitude and you think that today is going to be better than yesterday, that helps.
Recent research backs up Lillian's theory. Scientists are finding that many centenarians have a positive outlook. They are close to their family and are extroverted.
Shut up.
And to this list, one study even adds this trait, being stubborn.
Shall we?
Okay.
What do we got in here?
Well, I do these.
Nice. Keep your arms strong. Lillian, you're so great. What a badass, if you don't mind me saying.
10 of these. I complained at first. I can't do those exercises. I don't have time. If you want to do them, you will make time.
That's good advice.
It was good advice.
Lillian, you've inspired me. I was just blown away by Lillian in total, especially in her convertible.
Seeing Lillian with her boyfriend also made me think about my own relationship with my partner. We recently had the hopeful news that his cancer is in remission. This turn of events makes me so thankful for the medical advances of today, but still, I want our lives to continue to be happy and healthy for as long as possible. It makes me wonder, is there actually a way to stop growing old? It turns out there's one scientist who's working to truly understand the biological clock and actually reverse the aging process.
Thank you so much for meeting with me here at the Fountain of Youth.
Dr. Steve Horvath of UCLA is a biostatistician who's invented an intriguing tool that could help us find a way to roll back the biological clock. Steve created a blood test to determine biological age. It's widely considered to be the most accurate in the world.
So Dr. Horvath, why is it important to have a test like that?
Imagine we want to prove that this is the fountain of youth, right? Somebody would have to dive into here. We do a before and after measurement, you know? We would want to convince ourselves that it actually rejuvenated the epigenetic age of that person.
So it's really useful to have this clock as the metric to use if you're thinking of a treatment.
It's essential. A test for biological aging is really quintessential in order to distinguish snake oil from therapies that actually have an effect.
Dr. Horvath's blood test measures something called DNA methylation. Methylation is a process that regulates how genes function. Methyl groups get added to DNA as we age, kind of like rust on metal. Using his test, Steve has worked out the average rate that this methylation happens throughout people's lives.
By looking at this methylation change at several hundred locations on our DNA, we can very accurately measure the age of the tissue. Some people inherit good genes, and their epigenetic clock simply ticks more slowly. Example are centenarians. We analyzed blood samples from centenarians and their children, and sure enough, it was younger than expected.
They got lucky.
Dr. Horvath collaborated with a team to see if they could replicate this effect with a drug therapy. Over the course of 12 months, 9 men took a diabetes drug known as metformin, along with 2 other kinds of hormones. Steve tested the men's biological age both before and after the trial, and received some surprising results.
When I first ran the statistical analysis on my computer, I was really blown away. I couldn't believe my eyes. This cocktail even seems to reverse aging.
By how many years?
By roughly 2.5 years.
In effect, this mix of medications reverses that rusting of people's DNA, leading to visible changes in the body.
There was one gentleman whose hair was entirely gray, and after the treatment, it was darker again. There was repigmentation. If we are really lucky, maybe this treatment, this cocktail, really has a holistic effect. It affects many organs of your body. But first, this treatment has to be carefully evaluated and replicated.
Well, that's what makes me trust you, Dr. Horvath.
Although this study was very small, the promise of reversing the course of aging cannot be underestimated.
It's my dream that people get an annual measurement of their methylation. And then the doctor would say, you know what, you age a little bit too fast. Why don't you take this anti-aging treatment?
And do you think that could extend people's lifetimes to a healthy 100 years?
I am quite convinced that people live till 150. The question is only when.
With Dr. Horvath's approach added to the mix, I can more clearly see a path toward a future of extended life.
In the future, an age-reducing DNA cleanse comes in a simple pill. Taken yearly by people over 50, this therapy scrubs the methylation rust and rejuvenates the whole body at the cellular level. Most people's genetic codes can now be reformulated to the 97th percentile of optimal health, whether 50, 150, or 200 years old. it's possible to feel like you have the body of someone in their 30s.
As a scientist, I'm excited about these breakthroughs and the future that science is promising us. But as a human being, there are questions outside the laboratory that seem equally important to me. It seems that on many levels, our limited lifespan has defined who we are as humans. And I wonder how we'd change if we all live until 150 or even longer. Just because we can extend our lifespan, should we? And who will benefit from these treatments? Will only the privileged benefit from this extended life? When it comes to life expectancy in the future, it makes me wonder how class, race, and geography might play an even greater role than they already do. And how will the planet cope with human immortality? We're already struggling with overpopulation and resource depletion. But I do feel hopeful that science, technology, and pure human ingenuity can find solutions to these admittedly enormous problems.
I think by 2050, we'll probably have human beings that regularly make it to 120. I'm almost certain we're going to have individuals that live to ages that we've never seen before.
I want to make sure that no parent or no child has to lose someone they love.
There are always unexpected developments that nobody has foreseen. So there are these breakthroughs suddenly. And if we get lucky, we will be able to reverse the ages of people.
While developments in science are making extended human life an increasingly real possibility, it's clear that there are things we can all be doing today that may help slow the aging process, like exercising, following a balanced diet, and even simply just keeping a positive outlook. I'm heading back to the lab too, where, as a microbiologist, I hope in some small way I can also contribute to all of us leading happier and healthier lives.
Oh man, if I could live like Lillian, I would live to 100. If I could live like Lillian to 120, I would live to 120. I don't think we can predict the effects of what's going to happen to our world as a whole as we all live longer lives, but I'm pretty excited to find out.